Hello everyone, today we will talk about Hilbert transform. Hilbert transform, unlike the other conventional transform like Fourier transform or Z transform, it do not convert the signal from one domain to another domain. It basically converts a signal from time domain into time domain itself. So what different it do? It shift all the frequency of the input signal by an angle minus 90 degree, and it cause no change in the amplitude of the input. Let us see how it do it. If this is my Hilbert filter or Hilbert transformer and input signal is the xt, output is yt. Suppose the impulse response of Hilbert filter is h of t. Then this Hilbert filter is defined as, if the Fourier transform h of t is h of f, then Hilbert filter is defined as minus j signum f. This is the definition of Hilbert transformer. Now let us analyze it. Suppose what? If this is the signum f curve, we know how it looks like this, isn't it? This is minus 1 and plus 1 for f. Then how h of f will look like? The mod of h of f will be 1 for all frequencies, right? While the angle of h of f will become minus 90 degree. Why? Because of this minus j, isn't it? Now this is the frequency response of the Hilbert filter. Now let us see what effect it cause on the input signal. If the Fourier transform of x of t is x of f and the Fourier transform of y of t is y of f, then we know what is the relationship between y of f, x of f and h of f is y of f I can write as x of f into h of f, right? We know h of f is minus j signum f and multiply by x of f. This is the output frequency response of the output of this filter. Now let us see. We can easily observe that the magnitude of the output frequency response is same as the magnitude as the input frequency response, isn't it? While the angle at the output is same as the angle of the input, except it is phase shifted by an angle minus 90 degree. So this is what is the definition of Hilbert transform. It do not cause any change in the magnitude, but it cause a phase shift of minus 90 degree to all the frequency of the output. So from our discussion, what we can conclude that if this is the Hilbert transformer having impulse response h of t and input is xt, then its output will be yt, which will be x of t minus pi by 2. This is what is the characteristic of the Hilbert transformer. Also, we denote it by x cap t, which means this is the Hilbert, this got Hilbert transformed, right? That is why it is also known as Hilbert transformation, but unlike other transformation, right? Now let us do the time domain analysis of this. It means we will find the equation for h of t. Let us start with signum t. We know the Fourier transform of signum t is 2 upon j omega. It will be equal to 1 upon j pi f. Now I need to apply duality here. So let me tell you what is duality in Fourier transform. If a small x of t have Fourier transform of capital X of f, then capital X of t, mind the small x and capital X, then capital X of t will have Fourier transform of small x of minus f, right? This is what is the duality. Now let us apply duality here. So I'm taking this 1 upon j pi f to the LHS. It will become 1 upon j pi t, replacing f by t, and its Fourier transform will be this signum t will go this side and we replace t by minus f. Now since we know signum t is an odd function, So signum minus f will be minus of signum f, right? Multiplying both sides by j, what we will get? 1 upon pi t will have Fourier transform of minus j signum f. This is what we have seen. It is capital H of f, that is Fourier transform of the impulse response of Hilbert filter. So it will be h of t. This is what we were trying to accomplish, right? H of t is 1 upon pi t. So we can say 1 upon pi t, it's Fourier transform of minus j signum f. So also what we can say that output yt is equal to xt convolved with h of t. So it means xt will be convolved with 1 upon pi t. Now let us see some of the properties of Hilbert transform. The number one property is energy and power of both xt and its Hilbert transformed x hat t will be same. Number two property is xt and x hat t forms an orthogonal pair. They are orthogonal to each other. Number 3 point, both xt and x hat t will have same ACF, that is autocorrelation function. Number 4th, suppose I have two signals CT and MT, where MT is low frequency signal and CT is high frequency signal. Then the Hilbert transform of their multiplication, that is MT and CT, will be equal to M of t will be come out and it will totally applicable on the CT only. Some of the numeric question 1 is, we need to find Hilbert transform of t cube by 3 cos omega ct. So let us do the solution. We know Hilbert transform of m of t c of t is equal to mt c hat t, right? How? Where mt is the low frequency signal and ct is high frequency signal. It means Hilbert transform does not act on low frequency signal. So here we can see there are two signals are multiplied with t cube upon 3 seems like a low frequency signal and cos omega ct is a high frequency signal. So it means it will be equal to t cube by 3 and then Hilbert transform will be applicable on cos omega ct. We know that Hilbert transform cause a shift of minus pi by 2. So cos omega ct minus pi by 2 will be sin omega ct. Do next. We need to find Hilbert transform of sin omega t plus 2 cos omega t. We need to find this. Let us do solution. We know Hilbert transformer cause a phase shift of minus pi by 2 to every frequency component. So the Hilbert transform will be equal to sin omega t minus pi by 2 plus 2 cos omega t minus pi by 2. On taking minus sign common here, it will be sin pi by 2 minus omega t. On taking minus sign common here, it will be again plus, because cos is even, it will be pi by 2 minus 2 omega t, right? So sin pi by 2 minus theta is cos theta. We know sin pi by 2 minus theta is cos theta minus sin, as it is not theta, it will be omega t, plus cos pi by 2 minus 2 omega t, that is cos pi by 2 minus theta is sin theta. So it will be sin 2 omega t. This is the answer. Is we need to find Hilbert transform of 4 by t, right? So again it's very easy. What we need to do, it means the input is 4 by t. We need to pass it through the Hilbert transformer and we need to find y of t, right? Now there can be many methods to solve it, but I will use the very simple method. We know if input is xt, then output of Hilbert filter is xt minus pi by 2, right? So the Hilbert transform 4 by t will also be 4 by t with an angle minus pi by 2. We can also write it like this, 4 by t e raised to power minus j pi by 2, isn't it? So it will be equal to minus 4j by t. This is the answer. Now let us see question number 5. In this question, we need to find Hilbert transform of x hat t. What does it mean? That the input of the Hilbert filter is actually x hat t, and we need to find its output. That is, we need to find x double dash t. That's not any standard convention, I just made it from my side. And where does this xt come from? It must be Hilbert transform of xt. So right, so it means what happens when we do 2 times Hilbert transform, that's what we want to see. So let us see that. Now we know this, if this is y of t, so we know y of f will be equal to h of f, this multiplied by frequency response of this, let's name is x tilde f, right? Now this x tilde f we know is the multiplication of this and this, so it will be h of f multiplied by h of f into x of f, right? So it will be x of f, h of f is minus j signum f, so on multiplying minus j with minus j, it will be minus, right? Also when we multiply signum f with my signum f, it will be plus 1, right? So I will get minus of x of f. So y of f will be minus x of f. So what I can say, that y of t will be equal to minus of x of t, and y of t is this, so I can say that x tilde x hat t will be equal to minus of xt. So we can comment that by taking the Hilbert transform twice of the same signal, we will get the same signal with a negative sign, right? Now let us do one more numerical. Find Hilbert transform of 1 upon pi t square. Solution. Now let us do its solution. Suppose this is my h of t Hilbert filter and its input is any impulse signal, then output yt will be h of t convolved with del t. We know the convolution of any signal, this is t, with the impulse signal is this signal itself, so it will be h of t, right? So from here we can comment that Hilbert transform of impulse signal is equal to del t convolved with ht is 1 upon pi t, and it will be equal to 1 upon pi t, right? Now let us do Hilbert transform of differentiation of impulse signal. So now let me tell you a property. If xt convolved with ht is equal to yt, then if any one of them is got differentiated, suppose x dash t convolved with ht, the output will also be differentiated y dash t. Suppose if it is x dash t convolved with h dash t, the output will be twice differentiated, because there are two differentiation two time differentiation done, first time here and then here, so it will be twice, right? The same can also be written as x double dash t convolve with h of t. It will also be equal to y double dash t, right? So mind this property. Now let us apply this property here. Hilbert transform of differentiation impulse signal will be apply differentiator operator on any of the signal. I am not applying in this, I am applying on this. So it will be 1 upon pi t dash, it will be equal to del t convolve with minus 1 upon pi t square. We know convolution of any signal with the impulse signal will be the same signal, so it will be equal to minus 1 upon pi t square, right? So this is Hilbert transform of differentiation of the impulse signal. Now I am taking Hilbert transform both side. So Hilbert transform of del dash t will be equal to minus of Hilbert transform of 1 upon pi t square. Now we have already seen that by taking Hilbert transform two times we will get the same signal with a negative sign. So minus del dash t will be equal to minus of Hilbert transform of 1 upon pi t square, right? Minus minus cancel. So Hilbert transform of 1 upon pi t square will be del dash t. This is how we solve such problem. If it asks Hilbert transform 1 upon pi t cube, you can do one more time differentiation and you will get your result. Now let us see the application or significance of Hilbert transform. Hilbert transform is very important tool, very useful tool in signal processing in DSP, right? We will not go into detail, but you must have heard about the analytic signal. I will talk about it more in my next video on analytic signal. For any reals, for the time being, let me tell you that for any real signal, if xt is real, then for any real signal xt, it will have a corresponding analytic signal which will be equal to the real signal plus j x hat t, where x hat t is the Hilbert transform of xt. This is the analytic function of x of t. Now this is the real part, this imaginary part. I can also write it as in the amplitude and the phase form, it is by j phi t, where this amplitude actually represents the envelope of the real signal, this xt envelope, and this phi t is the instantaneous phase. By differentiating it, we can easily calculate the instantaneous frequency. This is very helpful in rotating engine, frequency detection of sweeping tone, and in many other application in DSP, right? Some other application of Hilbert transform is in sampling of narrowband signal, then medical imaging. Number 3, it is also helpful in the representation of band pass signal. Then it will be helpful in the generation of SSB SC, that we will see later on. Now let us see the characteristic of Hilbert transform. That is, we will see what are the characteristics of the h of t. Since we know h of t is 1 upon pi t, right? So this is actually a linear operator. Also, we can easily observe that it is a non-causal, right? Because it depends on the past value also. Then, since we know h of f, the curve of h of f, the magnitude of h of f was this, right? So for all frequencies, so it means it is passing all the frequencies, so it is actually a all pass filter, right? Also, since it is a non-causal, so it is not physically exist, we cannot design it, right? So what we do, we take help of quadrature filters. Also, it is very